Hi, Gunnar.
Hey there. Hey, Boris. Thanks
Hey,
for having me.
yeah, good to have you here. Thanks for coming.
Absolutely. It's my pleasure. I mean, it's great to do some conferences, right? I mean, not real ones in person, but,
Yeah,
it's as good as it gets.
it's totally like that. We would have loved to do it in person, but I think this was the compromise we had to do. But it's really fun to talk to people, to see talks, to talk to people who are in the same business and the same technology. So that's really fun.
Right. Absolutely. Yeah.
So,
Cool.
Gunnar, perhaps just to get started and warm up a little bit as a preparation for your talk, could you introduce yourself? A lot of people probably already know you, but maybe give a little bit of background, what you
Oh, yeah.
do, what sort of your interests are, and what you're talking about today.
Sure. Okay. Yeah, I will do it. So I work as a software engineer at Red Hat, and I'm working on one of the projects, and you might have heard about it in a talk earlier today. It's called Debezium, which is a tool for change data capture. And I believe Nicholas Frankel, he did the talk about change data capture, and I believe he may have mentioned Debezium there. So that's what I'm working on, during my working hours here at Red Hat. I've been working on different open source projects for quite a few years. I've been working on different Hibernate things before joining Debezium, and I'm one of the Java champions. And I guess that's also why I'm doing this particular talk, because to be honest, it's not totally related to my work, but this is more about my general interest in Java and what's new, what's happening, and I would like to share that with people. So that's why I'm going to do this talk here.
Yeah, that's great. I mean, you're also prolific on Twitter. I know you a lot from your tweets and from your publications, your blog posts as well, of course. And so, yeah, thank you for coming today.
So that's my manager speaking. Don't hang out that much on Twitter, I guess.
No, I didn't want to imply that. And regarding Debezium, I'll have a look at that. That was in parallel to another talk on this track, so I'll have to watch that in offline, but that should be really interesting.
I hope so, yeah.
I think we got a few more viewers already, so we're doubling the viewer count, and I think it's going up. People are hopefully returning from their lunch and settling in for a good session here. I would say we should get started with the stream.
Hello everybody, welcome to this talk to the moon and beyond with Java 17 APIs. Now, when I first was considering to do such a talk about what has happened in the Java APIs since version 11, I thought, well, this should be fairly easy. Let me just go through the list of new classes, new methods, let me add them to some slides, and boom, I should be done with the talk. But then I realized, well, probably that's not the most exciting way to do such a talk. Actually, it's probably pretty boring, and you might fall asleep pretty quickly. So I was realizing, well, every talk should tell a story, and this is what I would like to do today. Tell you or tell us all a story how Duke, the Java mascot, is traveling to the moon and how some of the new Java APIs can help him doing that. Now, some of you might remember the actual moon journey back in the 60s, and John F. Kennedy, the president back then, he set this mission for the astronauts. He said, we should commit ourselves to achieving the goal before this, in our case, talk is out, of landing Duke on the moon and returning him safely to the Earth. So that's what we would like to do today. And doing so, I would like to touch on 3 different APIs which have been added since 11. Firstly, the vector API for allowing us to do efficient parallel computations, then the foreign linker API for invoking native code, and lastly, the JFR event streaming API, which we can use to stream events out of Flight Recorder. Now, all right, let's get started with the vector API. And why would Duke want to use this? Well, he wants to get to the moon, and he needs to calculate how much fuel his rocket needs. And the vector API should help him to do those calculations, which surely are very complex, to do in a very efficient and very quick way. So that's the idea. Now, if you think about vectors, very often this question comes up, well, wait a minute, Java util vector, wasn't there this thing back in the days in the old collection API? And that's true, there's this type, but that's not what we want to talk about today. Instead, we want to talk about vector calculations. So now you might wonder, what is this? And well, what's important to know is here, each of or most of the modern CPUs, they have extensions to their instruction sets, which allow you to run the same computation on multiple operands at once. This is called SIMD, single instruction, multiple data. And to quote the JEP, which introduces the vector API, this is how this should work out for us. We want to introduce an API to express vector computations that reliably compile at runtime to optimal vector instructions on supported CPU architectures. And it should give us a significant performance gain. So that's the idea. Now, if you think about parallelization, well, we already have other means of parallelizing the execution of our code. For instance, we could scale out our application on multiple nodes in a cluster, in a distributed compute node cluster. Or we could think about parallelizing the code into multiple threads within a single process. And now here, with vector computations or with SIMD instructions, we add a third means of parallelizing our code within a single thread at the CPU instruction level. So this is what we would like to use. And now, until now, as Java developers, we couldn't directly take advantage of those SIMD instructions. The compiler, the C2 compiler, could sometimes auto-vectorize some code under specific conditions, but we didn't have the means of explicitly writing vectorized code. And this is going to change with this API. So there's 4 goals which the JEP designers set out to achieve with the vector API. Let's explore them a little bit. The first one, well, there should be a clear and concise API. So this means there should be an API which is easy to understand, which allows us to work with different data types in a unified way, which allows us to work with vectors of different lengths in a unified way, and so on. So that's the concise API goal. Secondly, this should be platform agnostic. Until now, you would actually have to program in more down to the metal languages like C or Rust to take advantage of vector instructions. And well, then your code would be very platform specific. Whereas now with the Java Vector API, suddenly Java developers are actually in an advantageous position because they can write, or the intention is that they can write vectorized code which will be executed transparently on the different platforms. So they shouldn't, or they won't have to care whether their code runs on an Intel CPU, for instance, or on an ARM CPU. This touches also on the third goal. So the vector API code at runtime should transparently be executed and compiled down into SIMD instructions for the x64 CPUs and the ARM CPUs AR64. And it will happen transparent for us. And lastly, there's this goal of graceful degradation. So this means if for whatever reason our code cannot be compiled into vectorized instructions, well, then the code should be executed in the traditional scalar way. Of course, we would then have a performance, we wouldn't get the performance advantage of using vectorized instructions, but our code would still work. So that's the idea of graceful degradation. Now, why would you want to use such an API? That's, of course, the key question. What are the use cases? And well, many use cases are there at library level. So let's say things like image or text processing, they will benefit a lot from this. So maybe you have already heard of this library SIMD-JSON by Daniel Lemire, which is currently C or C++ library. And there they use SIMD instructions for very efficiently parsing large files of JSON, so gigabytes per second. And well, while this is a C API currently, there is already a ticket which they have for also bringing this to the Java world using the new Vector API. So this, for instance, would be a very interesting use case where also we in our enterprise applications would benefit from this vectorized execution of the code. Other use cases, for instance, include encryption or machine learning. So something like TensorFlow might, for instance, be imaginable in the Java world. So let's dive a little bit deeper into the API. And for that, we should discuss a few of the terminology, a few of the terms there. So first of all, well, we have a vector, which really is just like a container, an array of values. Such a vector has a shape, which is its length in bits. So in this case here, it has a shape or a length of 256 bits. Also, there's an element type. So this means what are the elements, what type do the elements have which go into this vector. So here in the example, it's integer numbers, so 32-bit numbers. And now there's also the question, how many elements can we have in such a vector? And this is where those notion of lanes comes into the picture. So here we have 8 lanes. And now as our the element type has a width of 32-bit, 32 times 8, we are at 256, which is our entire shape. And lastly, there's this notion of a vector species. And the vector species combines a shape, 256-bit in this case, with an element type, integer. So here we have this particular vector species. All right. So now let's see how we can use this API. And this is an example which is from the JEP itself. So it is a basic computation where they want to use two numbers, or let's say two sets of numbers which come from input arrays. We want to multiply them with each with themselves. Then we want to add them, and then we want to multiply all this with -1. And now in the traditional sequential way, this is how it would look like. So you would just iterate through the array, and you would compare, or you would execute this operation for each pair of input values, and then you would write back the result to this array C. So that's pretty easy. That's how you would do it. Now let's see how it would be done in the vector API way. And there, it looks a little bit more complex, but actually it's not that tricky, as we will see in a bit. So let's walk a little bit through this code. So first of all, we need to define, or we need to set up this vector species. So in this case, we have float numbers. So we have a vector species of float. And now instead of actually mandating one specific length, we are trying to get as much as we can from the specific platform. So essentially, we want to work with the longest float vectors we can work with on the particular runtime environment. So that's what we get with the species preferred. So now we need to iterate still through our input arrays, but we will do it in steps which resemble the length of our vectors. So let's say we have input arrays with a length of 20 elements each, and maybe our length here is 8 elements. So this means we can do 2 iterations with the full vector length, and then we will have 4 elements left in the input arrays, and we will see what we have to do about those in a bit. But for now, we determine how often we can iterate through that with the full vector length. So this is this loop bound instruction, and then we do it. So we do those 2 iterations in that case. We achieve, or we fetch 8 elements, to stay with the example, from our input arrays into corresponding vectors. And then we do this multiplication, or this operation. So there we have this vector API where we do multiply, add, and so on, or negate in that case. And lastly, we write those 8 values in our example back to that C array. So we would have done this a few times, and there might be, as I mentioned, there might be the case that a few elements are left behind, so they cannot fill in full entire last iteration of the vectors. So this is why we have this processing here of the leftover elements in the scalar way. Now you might feel, well, this is actually pretty redundant, and we are doing the same sort of computation twice. Once in the vector way and once in the scalar way. And that's certainly true. So, well, we don't want to have this sort of dry, undry code. We don't want to repeat ourselves. And this is why there also is another means of doing that. And this is by essentially applying some sort of mask to the vectorized approach. By doing this masked vector computation, we would be able to also process this last chunk of the input arrays using the vector API. And we wouldn't have to do this scalar computation of the rest. Well, interestingly, when I tried this out a while ago, I figured this actually is pretty slow. So I suppose this was a case where it actually did this sort of graceful degradation and didn't really execute very efficiently. So this is why I'm here showing this scalar processing of the rest, but I'm pretty sure also this masked approach will be more efficient pretty soonish. Now, in terms of the API itself, it's really large. So we have just seen a few methods like add or multiply, and there's tons of methods there. So if you can see it here I just go from the letters A to B. So there's many more methods to come. And I really would recommend you to take a look into the API to see how large it is and what kinds of operations you can do. Now, to make it a bit more tangible, I would like to discuss one other example, which is maybe a bit more interesting. And this is this FizzBuzz calculation. So maybe you've heard this if you have been doing some sort of coding interview. It's a basic interview challenge where essentially you need to iterate through some input array with numbers, and now if the number is divisible by 3, you want to print out fizz. If it's divisible by 5, you want to print out buzz, and if it's divisible by 3 and 5, you want to print out fizzbuzz. And for all the other numbers, you just want to print out the numbers themselves. And I thought, how could we use the vector API and SIMD instructions for making this more efficient? So I was looking a little bit into the API, and I was coming up with this blend API or this blend method. So let's see how we can use it. And the idea there is, well, the sequence of, and I should say, being a developer, I adjusted the problem I want to solve a little bit. Instead of printing out fizz and buzz and fizz buzz, I print out those numbers -1, -2, and -3, because in the vector API we deal always with numbers. So then I thought, okay, the sequence of -1, -2, -3, this actually repeats. So we can essentially pre-calculate vectors with those values. And then in this case, if they have a length of 8 elements, they would repeat after 15 of those vectors. So I can pre-calculate those 15 vectors and then, apply them as long as my input arrays are. So that's the vector. It has those pre-calculated -1, -2, -3 values. And I also pre-calculate 15 corresponding masks. And those masks, they have a 0 for those indexes where we want to take the original value. And they have a 1 for those positions where we want to take this special -1, -2, -3 value. And now using this blend operation, I can just apply the vector to the input values, and I will get the desired output. So I will either get the original value, or I will get the special value if it's divisible by -3, -5, or -3 and -5. All right, so that's the basic idea. And then I did a JMH comparison or JMA benchmark to see whether we actually gain something in terms of performance. And as you can see here, well, actually my throughput was better by a factor 4. So that's pretty good. And now I'm pretty sure you can find better ways for solving this, but really that's not the point I want to make. The point I want to make is, well, even such a pretty basic problem, and maybe a more enterprisey problem, this could benefit also from those SIMD instructions. And I'm pretty sure if we are creative and keep thinking about how we can apply those vectorized calculations to our problems, we will find ways where we can benefit from this new vector API. Now, of course, the question also is, how does this actually look like in terms of the instructions which are executed? So I was curious, and I used this plugin for the JVM called HSDis, which allows us to take a look at the assembly code which gets executed, or which gets compiled by the runtime compiler, which then gets executed. So this is how you would run it using this print assembly command. On my blog, by the way, you can find out how you compile this HSDis plugin and use it with your program. And then, well, I took a look at the logs which were created, and I found indeed this VP blend VB instruction. So this is from the Intel SIMD instruction set. And now to tell what it does, well, here we have the description. It conditionally copies byte elements from the source operand to the destination operand, depending on some mask bits defined in, well, some other input register. So that's exactly corresponding to our blend call from the API. So indeed, this Java blend method got compiled down at runtime into this VP blend VB instruction. All right, so that's the vector API. And well, I hope Duke could use it to calculate his fuel consumption or his fuel needs. Now I would like to take a little detour and tell you a little bit how you can go about finding out by yourself what APIs have changed between different Java versions. So maybe you want to do a talk like this by yourself, or you just want to dive more into the details. And the question is how you can do this. And first of all, there's this tool, the Java Almanac. And this is a very useful website, which I really can recommend. You can compare any two Java versions there and see what has changed in terms of the APIs. So that's really cool. Let's say you want to upgrade from Java 8 to Java 17, and you want to find out what has changed there. Well, Java Almanac would allow you to do so. There's another page or another site which I created a while ago under the Adopt OpenJDK project. Now it's the Adoptium project, which is called the JDK API diff. So this goes a bit more into the depth. So there you really can find out about all the details down to the method and parameter level. So really, if you want to have the full picture up to all the most specific detail, this is how you would, this is what you could use. And by the way, this is based on a tool which is called JAPIComp. And this tool, JAPIComp, you also can use for your own API. So let's say you work on a library and you would like to make sure you don't break any of your public APIs with a new version. Well, then you could use this JAPIComp tool, and I really recommend it. Another one, this is pretty new. It's from Chris Newland. He just published it a few weeks ago. It's called the JEP search. So he has a very nice website there where you can search for all the Java enhancement proposals. And this is, well, again, it's a great tool. It helped me a lot for preparing this talk, actually. So let's say you want to find out where, in which Java versions the different incubators of the Vector API happened. This would be a great way for finding out about it. And lastly, if you are in Java 17, well, there actually the Java doc itself has this new tab. So you can go just to the Java doc and you can find out what has been added in terms of classes, methods, and so on in comparison to earlier versions. What you cannot find out is what has been removed. So for that, you would have to refer to one of the other tools. All right, so that's the Vector API. Now let's briefly touch on the foreign linker API. So we want to use this for accessing native libraries. In our case, well, Duke, he has fueled his rocket, so he now is ready to, or he needs to find his way. So he needs to find out how he actually should go there. He needs to navigate. And now he went to the internet, being a smart guy. So, and then he found this old ancient C library with Astral navigation implementation. So this is what you want to use. And I suppose it's a leftover from the Space Shuttle program. But it's written in C, and Duke, of course, he's a Java programmer, so he would like to use this API in his Java application. And the foreign linker API, this is what can help him to do so. To give some context there, this foreign linker API, it is defined under the project Panama. So in the OpenJDK umbrella, there's several projects which have been, or which are created there, and Panama is one which deals with the integration of the JVM and native code. And until this point, 3 JEPs, or let's say 3 JEP families, have been created under this project Panama. The first one would be access to native memory. So let's say you want to access memory off heap, you want to manage your memory by yourself without garbage collection, then this native memory API would be for you. Secondly, the native API, the JEP for accessing native APIs. So this is what we want to talk about here, which you could use either if you want to move parts of your code into native libraries, or as in the case of Duke, if you want to reuse existing native libraries. And lastly, there's the Vector API, which we already have explored before. So how can we go about the foreign linker API? And for that, I have, again, a very simple example, which is written by one of the contributors or developers of the JEP. And it's just showing you how you can call this getPid method from the POSIX interface. So what do we need to do? Well, first, we need to get this CLinker object and this library lookup object. And we want to get those objects because in the end, we want to have a method handle. And maybe if you have been working with reflection in later versions of Java, where method handles essentially are an alternative to reflection and they represent a method. In this case, a method handle represents a native method which you want to execute. So we get such a method handle, we describe its signature, its method name, its return and parameter types, and so on. And now having that method handle, we can execute it using this invoke exact instruction here. So this is how we could do it. And this would work, and compared to, let's say, JNI, the Java native interface, which you might remember, it's much easier. You don't have to think about any native code at all or compiling native code. You just can do this all from within your Java program. But then it's getting even easier. There's this other tool which is called JExtract. And JExtract goes a step further. It actually creates Java bindings for given native APIs. So you provide it with some header file, which you either would obtain from an existing library or you would create your own one. And based on that header file and its signatures, you could generate some Java binding code. So again, that's one of the examples provided from the JEP team. And here we use this JEP generator. And what's important to keep in mind is right now you still need to have an early access build from the Panama project. So while the foreign linker API, this already is an incubating module in the mainline JDK 17, the JExtract tool at this point, it's still not there yet. So you need to have a Panama early access build for that. All right, and then, well, having generated that code, you just can invoke this getPid method as any other Java method. So this is really very simple, very easy to use. Lastly, to wrap it up on the foreign linker API, there's this list of JExtract examples provided by Sundar Rajana. I hope I pronounced that right. So he's one of the developers of those JEPs, and he provides very interesting examples for using curl, for using Git, for using SQLite, and so on via JExtract. So this is really interesting to check it out, how you can use all those things, all those native libraries within your Java applications. I think that's really cool. All right. Let's do another detour, and this is let's talk a little bit about removed APIs. Of course, well, we always enjoy if there is new stuff which is given to us, but well, truth to be told, there's also things which are removed from the JDK. And the question is, well, why is this happening? It's happening because, well, there's always maintenance costs associated to things which exist in the code base, right? And of course, it's a question to answer, well, if an API is really not used a lot, maybe the effort of maintaining it is so high, it just isn't worth it. So let's get rid of this. And this is, for instance, the case in those APIs RMI activation. So that's an API for activating remote objects in the RMI context. Nobody's using it, so really it gets removed because it's just obsolete these days. Then there's this PAC 200 algorithm, which is a packaging algorithm or a compression algorithm for class files and jar files, which isn't used any longer after Java 8, so it's also obsolete. It just got removed. And there's the Nashorn script JavaScript engine. And now this is used, I would say, quite a bit. So when it was announced that this would be removed from the JDK, well, there was quite some interesting discussion there. But now, of course, not everything has to be developed within the JDK itself. We can also develop things elsewhere. And this is what's happening in case of the Nashorn project. So this is now a standalone project, which you can just pull in as a Maven or Gradle dependency since Java 15. Or you could even use the GraalJS as another very efficient, very performant JavaScript implementation. So you have some options there. And also related to that, there's two more APIs which have not been removed yet, but which are deprecated. That's applets. Again, they're really obsolete. All the browsers, they don't have the Java plugins any longer. So applets, they are just a dead technology. I think nobody will be sad if they are removed. But things are looking a bit different for the security manager. So this is used a lot. Maybe not with the intention, with the original intention, which for instance was to use it in the context of applets. But for instance, it's used by plugin systems or by plugin-based systems like Elasticsearch or OpenSearch, which use the security manager to isolate their plugins. So this will be a very interesting discussion, which we will see going forward. What will be a replacement for the security manager? What else could be used to provide those capabilities? So it's deprecated for now, and we will see how that goes. All right, so let's get back to our journey. Duke has fueled his rocket, he has determined how to get to the moon, and now he is actually sitting in his rocket, so he has started, and he would like to send back some telemetry data back to the control center on the Earth. And this is where the JFR event streaming API comes into the picture, because it allows us to stream monitoring and metrics events out of our JVM, and of course this is what also is driving the rocket of the Duke. Okay. So what is Flight Recorder? We should quickly discuss that. So it's a framework which is built into the JVM for troubleshooting, monitoring, and profiling. So you can use it for method profiling, memory allocation profiling, and it's centered around the notion of events. So there's more than 150 events which are raised by the JVM or by the class library, for instance, to tell you about things like class loading, object allocation, if there's a specific locks going on. It tells you about I/O, disk I/O, or network I/O. It tells you about garbage collection, all those kinds of things. And really, by examining those events, you get a very rich, very detailed understanding about the performance characteristics of your JVM. There's built-in events, but then there's also the ability to add custom events. So you can create your own ones which represent your own metrics data or monitoring data which you would like to emit. It's open source, so it used to be a proprietary commercial extension coming from the JRocket VM back in the day, but since OpenJDK 11, it's open source and everybody can use it. And what's key is it's meant to be used in production, always on. So it has a very low overhead, and what you can do is you can keep running it, you can keep it running, and for instance, with a capped size, so you would be able to go back to your JFR data for instance, if you find out by some alerting tool in production something has happened, maybe your request time goes up, then you could examine the flight recording from the last hour or whatever you have kept. So that's the idea. And now, or until this event streaming notion was added, this was file-based. So you would have to create recording files, and you would have to copy them to your local machine, and then you would use, for instance, the JDK mission control tool to examine those recordings. Here is a quick reference to this website, which tells you about all the attributes and all the event types which exist per Java version. So that's pretty interesting if you would like to see what event types exist on a specific version. So now we have event streaming. So as I mentioned, it used to be file-based. Now we have this notion of event streaming, which allows us to get events in real time in a low latency fashion as they happen. So what are use cases for that? Well, you could, for instance, use this to export data in real time to your monitoring tools. Maybe you do some sort of pre-aggregation, and then you can send compact data to your metrics collectors. You can use it for performance testing using a tool called JFR Unit, which I will talk about in a bit. Or you could, for instance, use this for predictive analytics. So this is something I find pretty interesting. For instance, what you could imagine is you could keep an eye on the garbage collection events and the duration of garbage collections and the frequency. And you might tell, okay, more and more garbage collection events are happening. And it is very likely that we are approaching a full GC in the near future. And then, for instance, you could expose this via some sort of health check if you are running on Kubernetes, and you would tell to the load balancer, okay, please don't send any more requests to this particular instance in our application cluster because it will go through a full GC very soon. And of course, this would impact our users and their response times. So there's quite a few interesting use cases for JFR event streaming, and I think it's a nice addition to the JFR. In terms of the API, it's really easy. It's pretty simple. It's callback based. What you do is you enable a specific set of events, or in this case, you enable what's called a configuration, which is a set of events and how they are enabled and configured. And then you start the stream and you register callbacks for all the event types. And then when there actually is an event of type JDK garbage collection or JDK CPU load, well, those callbacks are invoked. In this case, we will just print out the events. Now you can use this either in process or since Java 16 also out of process. So Eric Garlin, one of the developers of the flight recorder, he showed how to use this ability for building this tool, Health Report, which actually is a little profiling tool, and it has like 200 lines of code, so it's really not a lot. And it uses this notion of remote event streaming, which is based on a JMX connection, and you can use it to stream events out of a JVM to another process. It could be on the same host or on another host, depending on your JMX settings. And I find it really interesting with just a little bit of code, which you can see here on the URL, how you could build such a tool to gain this sort of insight into your remote VMs. So let's talk a little bit about this use case of performance testing. And the idea there is, well, for functional testing, and in particular functional regression testing, that's a very well understood domain. So you have your unit tests, your integration tests, and if you change the code of your application and some functionality fails, well, you will find out about this because your tests will fail. But things look a bit different if you think about performance characteristics. There it's very hard to implement automated regression tests. So if you think about metrics like latency or throughput, which are our defining metrics, well, having assertions on those metrics will be very brittle because it's very dependent on the execution environment. So if you would have such an assertion or such a test running on your developer's laptop or running on your production environment, it would give you very different results, potentially making such a test not very practical. And also it depends on the load of the environment. So let's say you are running such a test on a CI environment. Well, if there's other tests running at the same time, which take a lot of CPU, well, then let's say the throughput of your application under test, it would go up. And again, your test wouldn't be very stable. And this is where JFR Unit comes in. And its idea is, well, instead of asserting those actual metrics like latency and throughput, instead we test proxy metrics. And those proxy metrics, supposedly, they are more stable. And now, if we have failures with those assertions, they are an indicator that our actual metrics would be impacted. So examples for such a proxy metric could be, for instance, the I/O with our database. So for a particular use case, we should be pretty sure to be able to tell what's the amount of I/O we expect for that. And now if suddenly there's much more I/O, so we load much more data for the same use case than we did before, well, this might be a very strong indicator that there's an actual performance regression. So that's the idea of JFR unit. You could also use this, for instance, with other proxy metrics like object allocations or garbage collection behaviors. And the idea is, well, those will tell you potentially about your actual performance issues. It's implemented as plain JUnit tests. And then again, you would use the recording files, which also are created here. And you could go then to mission control to analyze what's actually going on. To show you an example, this is how it looks like. So first of all, you use this enable event to specify which JFR events should be active for this particular test. So in this case, we want to do this assertion based on socket I/O or database I/O. So we need to enable those two events, socket read and socket write. Then we run our actual code under test. So here, this is a Quarkus-based microservice. It's a basic CRUD application for managing to-dos. So we just invoke its API using this HTTP client here. And for that, well, this should yield a predefined amount of I/O. So we would determine this upfront. Then we have this barrier here, await events, and this is required because all this happens asynchronously. So we need to make sure that all the events which are produced by the test, that we actually have received them. So that's what this barrier is about. And once we have all the JFR events, well, we can use them for all kinds of assertions. So here in this case, we are filtering out our database I/O events. So those would be those socket read and write events on the database port. So we are not interested for this case, for instance, about the I/O on the web port. And then we would just sum up all the bytes values from all those events, and we would make sure in this case it's less than 480 bytes. So that's what we have defined upfront. And if we went to our IDE and execute this test, well, in this case, we have a regression. You see it allocates, or it does 4 times more I/O. And of course, well, now the question is, why is this happening? So now we could open the JFR recording and mission control, and we could, for instance, see where is this I/O happening, where is this regression coming from. So that's JFR event streaming. Now, let me tell you about one other tool, which isn't really an API, but I find it very interesting, and also is helpful for Duke because it helps him to get his rocket started more quickly. And this is AppCDS. So in a nutshell, what is this about? Well, it is about speeding up the starting times of your applications. So you might have heard about GraalVM and the ability to compile native code, but you also can use, or you can have some nice benefits in terms of startup times on the JVM itself, and CDS is giving this to you. So it's CDS, that stands for Class Data Sharing, and what it does is, well, it takes all the metadata for the loaded classes and stores them as files. Now, class loading at application startup time, this takes quite some time, and if we actually can just take the preloaded data from a memory mapped file, this will be much quicker. So that's the idea of CDS in a nutshell. Have those class metadata in memory mapped files and just load it directly and be done. There's this notion of default CDS archives, which exists since Java 12. So this is CDS data for the classes of the JVM. And then with the notion of app CDS, application CDS, you can do the same for your own application-specific classes. And it's very easy actually to do it. You just run your application once, so it loads all the classes you are using. You specify this archive classes at exit option, and this will create an archive file if you stop your application. And then now when you restart the application, you can refer to that CDS file using this shared archive file option. And now it will use the memory, or it will memory map this metadata, and it will start up more quickly. To see what you can expect, again, that's a Quarkus application. Now in JDK 11, the time to first request, or the time to first response, I should say. So this is really when the first response was sent back to the caller. This used to be 2 seconds in this example on OpenJDK 11. In 15, it's a little bit quicker because, well, we have this notion of CDS for the default classes. And now if you also use AppCDS for our own classes, well, we go down to 0.8 seconds. So quite less than half of the original value on OpenJDK 11. Now, the nice thing is, and this is what we see here, well, this adds a little bit of size to the distribution of our application because we have this archive file. But then if, for instance, we use JLink to just distribute our application with those JDK modules, which it actually needs, we still get away with a smaller container image in this case, and it's really like a win-win situation. Another example, Apache Kafka. So I did a test a while ago. So this shaved off almost a second from the time up to readiness for Apache Kafka, which of course is great, for instance, during testing. So maybe you think, hey, I don't start Kafka that often. It's a long-running process. Well, that's true in production, but for testing, you tend to start it up very often. And shaving off that second, that's a great benefit. And it comes very easily, as we have seen before. And with that, our journey is pretty much done. So Duke has achieved his goal. So he went to the moon, and well, I would say we succeeded with our mission. So we used those different APIs like Vector API, for Linker API, event streaming, CDS, and all those things come very nicely together. And we, or Duke in this case, made his mission in a successful way. Now, if you think back to the mission statement, there he said, well, we want to send him to the moon and get him safely back to the Earth. Well, we will talk about that at another time. Now, the question is, what do we think about? Is it worth upgrading to Java 17? And I would say yes, it definitely is, because if you think about it, there's really substantial improvements across the board. So in all those three categories, language, runtime, and API. So in this talk, we have been primarily focused on the API improvements, but also there have been lots of language improvements, like switch expressions, text blocks, records, and so on. And also in the runtime, like all the JFR improvements, garbage collection improvements, I would say a very worthwhile upgrade. From 11 to 17, it should be much easier, in particular if you are using modern, up-to-date versions of your dependencies. So I definitely would recommend maybe not to go to production right away, but to give it a try and see how your application behaves with Java 17 in some sort of testing environment. Now, the cool thing about the OpenJDK project is it's a community project, and Red Hat, which happens to be my employer, is also one of the contributors. And just to tell you a little bit what they are doing, well, for instance, there's this notion of the low latency garbage collector Shenandoah. So you have this open source added in one of the recent Java versions. There is support for JFR events and native GraalVM binaries. So that's a very cool feature. If you would like to work with custom JFR events, you now can use them also in your native GraalVM binaries. The engineers did the original port of OpenJDK to AR64. This was back then for Linux, but also recently in Java 17, we had those ports for Windows and macOS on AR64, and they're all based on this initial Linux AR64 port. And lastly, a very interesting project where Roman Kenke is working on, it's Project Lilliput, and this is about shrinking the object header size. So potentially this will give us much more memory efficient applications going forward. So, and I find it very interesting to see how all the contributors from Oracle, Red Hat, and all the companies involved with the project come together and move OpenJDK forward together. Lastly, a few resources. So I had already mentioned this JEP search by Chris Newland, but I really like it, so I'm sharing it here again. If you would like to learn more about some of the things I discussed, you can go to my own blog. I discussed there the Vector API, JFR event streaming, CDS, and quite a few other things. And lastly, if you would like to know more about performance regression testing using JFR Unit, well, then you will find this as an open source project on GitHub. That's pretty much all I had for you. I would be very happy to stay in touch with you. We can discuss here at the conference, so I think we will be able to discuss later on. Also, feel free to reach out to me via email or reach out to me on Twitter, and we can discuss everything OpenJDK and open source. That's all I had for you. Thank you so much for watching.
So you talked in the beginning about the Vector API, where we basically get easy access to SIMD instructions in Java. You know, if Oracle already put some work in to sort of change certain APIs to incorporate Vector API usage, as like did they take any JDK or class library methods and then put some Vector API in there?
So I don't think they have done this yet because it's still an incubating module, right? I wasn't very outspoken about this during the talk, but it's not a finalized API yet. So details are still changing. And I believe even in 18 is going to be yet another incubator round. So I would imagine they do some sort of internal testing, but they certainly cannot rely on it, to be part of the JDK proper yet.
That makes sense, because I was wondering, I was talking to Nikolai before, we use a bunch of image I/O, and I could imagine the image operations would be a good candidate, like scaling, resizing, things like that.
Absolutely, yeah. So when I did this blog post about the FizzBuzz stuff, I thought about doing something with images before, because, as you say, it lends itself very naturally towards such a vectorized solution. Like you want to change the brightness values for all the pixels. That would be, I guess, an easy example. But then I thought I'd go for the FizzBuzz stuff because it's even easier for a blog post. But definitely images would be very good.
FizzBuzz is perfect for demonstrating.
Right, that's what I thought.
I'm glad I don't use that in interviews anymore.
Well, you got to do it the SIMD way.
Yeah, it's true. If people can solve that, they get extra points. Definitely. After I wrote so many things down that I need to have a look at. For example, the JExtract samples. You mentioned this test project where somebody has combined a bunch of examples on how to use it for an API. I think I will check that out because I was wondering.
Absolutely.
What maybe could be things that we can also use and look at there.
Yeah, they have lots of stuff. I mean, the SQLite stuff I believe would be pretty interesting. That's one I would like to look into because, well, having SQLite support in Java, that would be pretty cool.
Yeah.
And all sorts of popular libraries, right? Like the Git library or the curl library. I mean, those are interesting things. And I'm not sure about RocksDB. That was another one I would be very interested in because I tend to be interested in data stuff. But I'm not sure whether they have that one there yet.
Because I think there are some libraries, right, like Java wrappers for Git, for example. I think there's a JGit project where they try to provide a Java wrapper. You think they use probably at the moment the standard FFI or whatever was possible JNA in Java until now. Right. Are those all candidates for migrating to the new APIs, you think? There's basically no constraints? Or?
I would expect so, yeah. I mean, of course, they need to find an answer for themselves. How do they think about, backwards compatibility? Because, well, if they move to this API, it means, there's a certain minimal Java base version they would require. So I guess this would take some time. But eventually, I would totally expect, this to supersede JNI or JNA, which actually wasn't that bad. But I would expect people will use this once, it's part of the JDK. It has been around for a while.
Right. Yeah, cool. I also look forward to trying that out. I was thinking maybe Git would be a nice example to do a few tests with.
Definitely, yeah.
You mentioned a bunch of deprecations, which I find also to be interesting because that's sort of a big departure for the Java platform, right? It used to be almost unthinkable that anything would drop away, which was both good in the sense of nothing changes, so you can always rely on anything being there. But on the other hand, I think the Oracle and the Java community was a little bit locked into old things that were still hanging around. So I'm actually glad that they're starting to deprecate very carefully.
Yeah,
a few older things, right?
Definitely, and I mean they do. I would say they do a great job in the way they do it. So when I was researching for this talk, I was also looking into this a little bit. So for instance, they will go to Stack Overflow, they will go to all kinds of forums, mailing lists, and to just see when, or is the stuff being used, or when has it been used for the last time. So for instance, in case of the RMI activation stuff, I believe they had the reference. They found a post on the Java Ranch forum from 2003, which was the most current ever mention of this. And then it's a reasonable thing, I would say, to just remove this. And so they really do this kind of exploration to be sure, okay, this is something we can remove, or this is something maybe it should stay around. Now, in case of the security manager, I mean, as I mentioned, there definitely is, I would say, a substantial user base for that. So this one will be very interesting. I'm curious how this is going to play out.
That's going to be real interesting. You mentioned that you used it on Hibernate projects. I don't know if you meant internally at Red Hat or people using when you use Hibernate or
So exactly. So there was a time where the guideline was that all our libraries we worked on, they should support usage with a security manager. So it never was the case for Hibernate ORM because this had been around forever and it would have been super complex to retrofit it. But for instance, Hibernate Validator, the implementation or the reference implementation of B validation, this one fully supports usage with the security manager. So we, we set up a specific testing infrastructure and everything to make sure if you have a security manager, it works. And this is the minimum set of privileges you still need to work with that library, but it's really cumbersome to use. It requires lots of consideration to do it right. You can easily do it the wrong way, and even if you use it technically the right way, you might accidentally still implement your things in a way where you still expose public APIs, which let the user to do everything which you meant to prevent with the security measure. So there's lots of subtleties there.
Yeah, I remember doing some work on OSGI-based plugin systems where we also wanted to use a security manager as sort of a sandbox, but it's so hard to guarantee that nothing will leak out. So it gives you a little bit of security maybe, or a little bit of isolation, but it's something completely different from, say, I don't know, containers or some other level of isolation that you would need.
Yeah, and I mean, I think for security, the attention really has moved towards process-based isolation. So maybe if you have some sort of plugin system, you would rather think about it in terms of having multiple processes, like your tabs in your browser. They are separate processes, right? So and then you benefit from all the security primitives of the operating system. In terms of a sandbox, I mean, Ron Pressler, he did a very interesting example where he showed how you could do a sandbox by means of custom class loader, where you would just whitelist specific classes or methods, which is doable. But then, of course, the security manager, it also works on a data level, right? So you can specify, okay, not only file I/O, but you can do file I/O with those particular files. And this is something which you couldn't do in a class loader. So I believe there is certain usages of the security manager where if it were to be removed, it's not quite clear actually how it would look like instead.
Okay. So do you then talk to Oracle about these things as well as Red Hat? Like, you're a close collaborator on the OpenJDK. You guys contribute stuff, a lot of projects and things. Is there like a process going on where you discuss? Is it all the open mailing list, or are there some extra ways to do that, or both?
Okay, so first of all, I'm not a member of the OpenJDK team at Red Hat. I happen to know many of the engineers, but I'm not part of that team, so I'm not super familiar about the collaboration. But what I can tell you is, there's definitely lots of public discussion going on for sure on the mailing lists. Red Hat is, I believe, the second largest contributor after Oracle. So I mean, whenever people say Oracle is not doing a good job, I would say that's completely bollocks, because they are the biggest contributor by large. But then, Red Hat is in second place, so that's pretty cool. I would expect there's some sort of backdoors communication going on, but naturally it's backdoors. So, even if I knew, I wouldn't mention it here.
It's just always interesting to get a little bit of an insight in how things work and what's going on, because especially now that the JDK has become so much more open, literally, right? So many people contributing. It's become more interesting, but also more complicated. I was like, last year, I heard about for the first time that Microsoft has like a large team working on Java, which was already a bit mind-blowing. I mean, I know it from back in the 2000s, like 20 years ago, they did something, but this was a new initiative. So it's interesting how the ecosystem is expanding. Definitely.
And to add on that, I mean, they did the Mac port, right? So I find that particularly funny.
Mind blown.
It's also nice
strange times that we're living in, Cool.
It's awesome.
At the end, I've already wrote down some notes with GFR unit, because I need to check that out myself. I didn't know about these events. That's going to be really interesting to look at. But at the end, you talked about this class data sharing. I think we did some experiments with that back in our software. In the beginning, it was a bit cumbersome to basically extract these archives.
Definitely,
I think it's become a little bit easier.
Yeah, absolutely.
Do you know how it is? You mentioned that it basically extracts, or it when you run it to create an archive, it basically saves everything that you use, all classes that were loaded. Does that mean all the classes in your class, in your jar files, or does it just mean the ones that you're actually using or activating? Or what is the...
It's the latter. So, if your class... if you have, 10K classes in your application and you only load 100 of them, then only those 100 would go into the archive. So that's why you need to do this, trial run, or however you want to call it, where you touch your use cases, or so to make sure those classes which you want to have in the archive, that they are actually loaded. And then you could think about having multiple flavors of that, right? So maybe your application supports multiple modes of running. Maybe you have some sort of, some sort of online mode and some sort of batch mode, and works with different subsets of its classes. Then you could think about having separate CDS archives optimized for those use cases.
Right. And is there some fallback mechanism that if I don't include some classes that I maybe load at runtime later, or I do some reflection or something, does it then do
Yeah,
that
it
in a
will.
normal
Then it
way?
will just do the regular class loading, right?
Okay.
So whatever isn't in the archive, it will just be regularly loaded. And they also increased the kinds of classes which qualify for that by a lot. So in 15, I believe they did lots of changes where, classes which back lambda expressions, they were all now eligible for CDS. So if you do some testing between 11, 14, 15, or now 17, it always started up faster because more and more classes got eligible for CDS.
Nice. So that basically means that it sounds like it's almost free. Like if you have the space, and let's say you have maybe the build step and build time. Okay.
Definitely. And even if you do an archive with all the classes, which is what Quarkus can do for you if you want it to do, as you say, it's for free, right? So you pay a little bit of disk space or maybe image size if you deploy your application as a container image. But I would say this shouldn't matter that much, right? Because you would put it, for instance, into some sort of base layer, and then it wouldn't have to be redistributed all the time. And yeah, you benefit from this startup time improvement. Now the question is, do you need that, right? So if you do some sort of long-running batch kind of thing, well, it doesn't matter whether you save a second or not. But then even with Kafka, for instance, as I mentioned, so during testing, you tend to start it up a lot. And then, well, if you save a second each time, it actually is quite nice.
Right. Yeah, cool. I mean, we also still have a desktop application legacy that we maintain. That could be a very good use case, maybe to increase start times a little bit. I actually have a question from Daniel Dittmar in the chat. He's asking if you use CDS during development, when classes change during, you're compiling and recompiling, is that still a benefit? Can it still be a benefit for somebody, or how does that look?
How is CDS during the development where classes change regularly? Well, I would say, I'm not sure. Do you mean during your own development? I guess you wouldn't benefit much from it, but more, you would keep working on your classes, and at some point you create your deliverable, like your jar or container image or whatever, and then that would be the point in time when you create the CDS archive, right? It wouldn't be you do it and you benefit whenever you start your unit tests in your IDE, not that much.
And you mentioned also the default CDS archive, right? Something that's included in the JDK. Is that included, or is it something you have to generate? Do you know?
No, it's part. It's I don't know, since 12 or 13 or something. That's just there by default.
Okay, cool.
But then there's also some subtleties. For instance, it's platform specific. So, for instance, if you wanna, create a containerized application while you are running on macOS, then you couldn't create the CDS archive on macOS because this would be platform specific. So you would have to actually build the CDS archive also in a container. So there's some subtleties also to consider.
Okay, cool. Yeah, Gunnar, I think we're almost out of time, and it was really, really interesting. Such a lot of topics to dive into and to try out with the new Java versions. Any final words from your end before we close this down?
Nope. As mentioned, thanks for being here, everybody. If you have questions, feel free to hit me up on Twitter. And also, there will be this panel with Falk and Holly later on, and myself and Nikolai, I believe. So if you want to join there, we will definitely be very happy to have you there.